Alright, this will be part 2 of the study guide, which is basically just most of the second page. You see in our study guide, there's 2 parts where we're going to find the inverse. One's where we're looking at exponentials because we have a variable in our exponent, and on the very last page is where we're looking at like square roots, cube roots, all those kind of things. But finding the inverse, the process of it is pretty much the same. First thing you're going to do is you're going to set your equation equal to y. Then you're literally just going to switch x and y. You're going to change their positions in the equation. So wherever x is, put y. Wherever y is, you put x. And then essentially you're going to solve for y, which is to get y by itself. Alright, so if you look at this equation, we have an exponential equation because there is a variable in our exponent. So we're going to start out by setting our equation equal to y. Since it's already there, we don't have to do anything with that. The next step is going to be to switch x and y in the equation. So literally you take y, put it where x is, and then x where y is. And then what we're going to do is we're going to find the inverse of this. We're going to get y by itself. So the first process of that is you have to get the base by itself, because we're going to rewrite this as a logarithm, because that's the inverse of an exponential. So you've got to get that variable, its base and the exponent. You got to get that by itself. So we're going to add 3 to the other side. So we're going to have x plus 3 equals 2 to the y minus 2. Now, since we have that by itself, what we can do now is we can rewrite this as a logarithm. So remember, we rewrite as a logarithm, we're going to keep the base the same. So we're going to have log 2. And then you just switch x plus 3 and y minus 2. So it's going to be log base 2, x plus 3 equals y minus 2. And then to get y by itself, we're just going to add 2 to the other side. Now, I'm going to add 2 to the front of it, okay, just to keep things shows out front. So we're going to add 2 to the front. That's not 2 times log. That's going to be 2 plus log base 2 x plus 3. And we're going to get y by itself. And let's go back and look at that last answer. So add 2 to the front of that. 2 plus log base 2 x plus 3. You could absolutely add the 2 after the parentheses, but just make sure that you show that there's parentheses that's not included with the x plus 3. Solving log equations. This is some of the more recent stuff we've worked on, so it shouldn't be too new. We're going to get the logarithm by itself. So anything that we need to add, subtract, or divide, we're going to do that first. Then we're going to rewrite the logarithm as an exponential and then evaluate it using a calculator or our order of operations. Alright, in this equation, the log is already by itself. Because that x plus 2 has parentheses around it, we know that it stays with the logarithm. So we don't need to move anything. So our first order of business is we're going to rewrite this. So remember, you're going to cancel out the logarithm and then switch x plus 2 and 7. So our exponential is going to become 3 to the 7th equals x plus 2. Evaluate 3 to the 7th power using a calculator. You get 2,187. And then get x by itself, we just essentially have to subtract 2. And our answer is 2,185 would be your final answer to that. Now with this problem, that minus 12 is not inside the parentheses. It's not with 3x, so we can't consider it a part of the logarithm. So here what we're going to do is we got to get log base 2 3x. We have to have it on one side and everything else on the other. So the first thing we need to do is we need to add 12 to both sides. So that's going to be 7 log base 2 3x, and then 37 plus 12 is 49. So we have that 7 out front. That's 7 times the log, so we need to make sure that we divide that 7 to the other side. Once we divide the 7, we get log base 2 3x equals 7. Now we have the log by itself, so we're going to rewrite it as exponential. So you're going to cancel out your logarithm, switch 3x and 7, switch their locations in the equation, and you get 2 to the 7th power equals 3x. And then just evaluate. So 2 to the 7th is 128. Divide both sides by 3. X is 128 over 3. Alright, we're graphing logarithms. Remember, our first and foremost thing we want to do is we want to find the asymptote, which is where you take the inside of the parentheses of the logarithm. You set that equal to 0, and that is a line, that is a vertical line that crosses the x-axis, in which your logarithm graph cannot cross. So we're going to find the asymptote first. We're going to select 5 numbers to the right of the asymptote. Remember, you can't include the asymptote, so you got to pick 5 numbers to the right of it, and then evaluate using our change of base formula. All right, with this equation, the first thing we want to do is we want to locate the asymptote. So we're going to take what's inside the parentheses and set that equal to 0. So x minus 2 equals 0. Add the 2 to the other side, and you're going to get an asymptote at x equals 2. So that line right there, that's the first thing you'd want to draw on your graph. Find where x equals 2 on the x-axis. Draw a vertical line crossing that point, and that is where your graph cannot cross. Since we know that's our asymptote, we need to pick the first 5 numbers to the right of that. So numbers to the right would include 3, 4, 5, 6, and 7. Okay, so that's going to be the x's for our xy table. Now we've got to go back and evaluate those x's by plugging them into our equation and then using the change of base formula. So remember, your change of base formula is going to say that you're going to have log of whatever's being evaluated at. So in this case, the x is 3, so we're going to plug in 3 minus 2. And remember, the base, the log base, always goes on bottom. They both start with b. Just a way to remember that. The base goes on bottom. So you plug in x, log 3 minus 2, and we're going to divide that by log 3. And then if you type that in your calculator, you'll get an answer of 0. Then we plug in 4. Okay? Once we plug in 4, we get an answer of 0.63. And we're going to go through there and complete that process until we have our table filled out. Once you have your table filled out, now you have your xy coordinates that you're going to plot on a coordinate plane. All right, graphing a logarithm is just like anything when you have an xy table. Remember, we talked about the first thing we're going to do is we're going to graph the asymptote at x equals 2. So that x equals 2 is 2 to the right. We're going to draw a vertical line. I'm going to have a dashed line to denote that it is an asymptote. And then after that, we're just basically, I'm going to label my x and y axis and then plot my points and connect my dots. And remember, logarithms have a smooth curve that connects the dots. Remember to scale your y-axis however you need to. Just plot these things and make it as neat, as accurate as possible. All right, here we're going to look at the trick section of our study guide. And basically we're just going to run down how to do these problems and what they mean. The problem it gives us if tangent x is 2/3 in quadrant 1, so that's important. So we know we're in quadrant 1. So really what that tells us is that x and y are going to be positive because in quadrant 1 they're both positive. And with that information, we want to try to figure out, well, what is sine? Well, the first thing we want to do is let's draw a triangle that's in quadrant 1. So remember, quadrant 1 is the top right-hand corner. Always start from your origin to draw your triangle. And so tangent, if we recall, tangent is opposite over adjacent or y over x, however you need to think about it. So opposite would be 2, adjacent would be 3, the y coordinate is 2, and the x coordinate is 3 based on the coordinate plane based on your unit circle. So what we need to find the hypotenuse first, because sine deals with opposite over hypotenuse. So Pythagorean theorem tells us 2 squared plus 3 squared is going to equal c squared. So 4 plus 9 equals c squared. 4 plus 9 is 13. Remember to take your square root. So our hypotenuse is the square root of 13. If you can simplify it, you need to. If you can't, don't. Alright, so once we figured that out, we need to find sine. So sine is opposite over hypotenuse. So the opposite side of our angle, if you look down there in the left corner, okay, where theta is, opposite of that is 2. The hypotenuse is the square root of 13. Make sure that you rationalize your denominator like we've done so many times before, and we get a final answer of 2 square roots of 13 over 13. This problem is a little bit more interesting because now we have a negative, okay? And when we look at a negative, we got to understand that how the quadrants work. So if we were to draw our quadrant in quadrant 2, we know that on the left-hand side, all x coordinates are going to be negative. Okay, so your x coordinate has to be negative in this, and that all y coordinates are still going to be positive. So when you think about negative 3 over 4, you can't just put the negative in terms of the order of that it is. Now in this case, adjacent over hypotenuse, it is going to work out where the negative needs to go with the adjacent side, but you always need to make sure you understand what quadrant you're in and what that means about the quadrant. Something in quadrant 3 is going to have a negative x and a negative y. So just because your answer may be positive, or what you're given is positive in quadrant 3, it's not always going to be that. So please make sure you're checking. Please make sure you're looking at what quadrant you're in. In this case, we're in quadrant 2. So what that means is our x value is going to be negative, so the 3 is going to be negative there. Our hypotenuse is 4, so we need to make sure we find our opposite side in order to get tangent. So you're going to work Pythagorean theorem. Remember, the hypotenuse is always c squared, so we're really going to be looking for b squared here. Solve that out just like you would any other equation, and you're going to come up with b is the square root of 7. Okay, so we have that labeled now, so we're looking for tangent. Tangent is opposite over adjacent, so tangent would be the square root of 7 over negative 3, and just know that a negative on bottom is going to make your answer negative. Let's go back and look at that and make sure we understand. So since you're dividing by negative 3, because we have to include the negative because it's quadrant 2, our answer is going to be negative. So just be very careful about your signs when you're dealing with the quadrants. All right, and this problem says find the angle if sine angle, okay, find angle A if sine A is negative 1/2 in quadrant 4. So here what you're going to do, you're going to locate quadrant 4, which is the bottom right-hand corner. You're going to go find the y-coordinate because sine is y, sine is our y-coordinate. Find the y-coordinate that is negative 1/2. So sine is negative 1/2 at 330 degrees, okay? So if it asks you for degrees, your answer would be 330 degrees. If it asks for your answer in radian, you would need to get the radian answer, which is going to be 11 pi over 6. So that one's a little bit easier. Figure out which quadrant it is, know which coordinate you're talking about, x, y, or y over x, whichever one is asking, and then evaluate it at the degree of the radian, depending on the question. Hope this has helped you a little bit. We'll cover part 3, the rest of the stuff we haven't covered in these videos at a later time.